I'm Alex Williams, the New Stack, and today I'm live at Palo Alto Networks studio in Santa Clara, California. Joining me today for a discussion about DevSecOps, building best practices with cloud-native security, are Ben Bernstein, Senior Vice President of Products and Engineering at Palo Alto Networks. Hey, Ben. Matt Chiodes, Chief Security Officer, Public Cloud at Palo Alto Networks. Hey, Matt.
Hey, Alex. And
joining us from the East Coast, Jabo Long, Senior Vice President, Cloud Security at Citibank. Thank you all for joining us. I'd like to get started. I really like to focus on the people when we do these types of interviews because it helps bring things into context. And I really wanted to ask you, Ben, what is working? What is not? What are you seeing that is evolving right now?
Well, I'd say that a lot of the DevOps movement has been about almost democratizing things for developers and listening more to what they do. And I think that, first of all, that DevOps movement enabled a lot of more faster, not just digital transformation on the business side, but digital transformation. I mean, just transformation of the processes and the things that people do to deploy software, to build software. New programming languages that were usually dictated by the company are now available to everyone. So it's all about the people and giving them the ability to choose the best tools for themselves. And security has traditionally not been that way. And what you can see is that for us as a security company, it's very important to empower the people to make the right security decision, but also give them a set of wide range of capabilities to pick and choose what they think is most important. I mean, we can be prescriptive to a point, but we have to understand that this is no longer a situation in which we dictate everything to the customer or the CISO dictates everything to the development teams or the cloud teams, etc.
So Matt, what's your view? How is excellence defined and accomplished?
Yeah, I mean, I think similar to what Ben said, the power has shifted. When we look at how things changed over the last decade in most corporations, a lot of times that power sat with the IT teams and the security teams. But with this whole move over the last decade to DevOps, what we've seen is developers now have that control. And so I think when we talk about what excellence looks like, it really is what I've seen is organizations that are doing this well are organizations that really start to focus first on standards, right? And from a security perspective, making sure that those standards are baked in as part of development processes. The organizations that get that right are able to scale very well. What I like to say is that you can't scale what you haven't standardized on.
So Jabo, I'd like to ask you that same question. What is working? How do you define excellence and how's that accomplished?
I'm doing cloud security engineering for a bank. As a cloud security engineer, we deliver security as a service to the clients. Our clients are the developers on business side. They are developing the applications for consumer banking and investment banking. So it's like working for a hotel and deliver room services to our guests. There are some similarities. Because like any services, the excellence of service is defined by customers' happiness and can be accomplished by delivering the services quickly with high quality. The services we deliver have to be easy to request and easy to consume as well. For example, when we deliver secrets management as a service, and certificate services to our applications running in containers. Those applications in containers can be anywhere. It can be in AWS, EKS, Google GKE, or on our on-prem OpenShift cluster. But one of the service measurement is the latency. From the time the client requested the service to the time the client received the service, how quick it was. So if a developer is developing a web microservice and need to request a web server certificate, we would like to provide a simple REST API for them to call to request the certificate as a service in a secured way and give them back a PKI signed certificate within 1 second. In regards to how to achieve the excellence, there are 2 things we do. First, leveraging the new technologies from industry as always, but more importantly is the automation in the process. The process includes onboarding the clients with automated registration for them to check in. So this we call it as governance process. And also deliver the services through a pipeline like CI/CD, as well as continuous monitoring of the whole entire infrastructure with guardrail in place so that our clients can enjoy in a safe place we provide for them to do the coding. And without worrying showing up on Wall Street Journal for being hacked.
Okay, moving into the next question. Ben, I wanted to ask you about how you're seeing people's workflows actually change. What's some of the proof that you're seeing? What are some of the initial practices you're seeing people develop when you're out there talking to customers?
Well, the most obvious thing that we're seeing is that in general, the DevOps movement has seen 2 types of deployments, the greenfield deployments and the lift and shift deployments. To be frank, the one that's more successful is the greenfield, because a lot of the traditional workloads have been so baked into a monolithic idea or a process or something that doesn't really enable to break it down into small pieces and create these agility, both in terms of people and how they able to deliver software in a more continuous way, as well as the technologies themselves that you could always treat cloud as an outsourcing of what you have on premise, but then you haven't been using any of the advantages. So to be able to use the advantages, you need to sometimes go very deep into the rabbit hole and change some things, and so it's typically easier to do that when you build it bottom up than just taking something that's already out there. So if we're talking about banks, and we might get some more data on that, but typically a bank would start not with the core application, but would actually start with the more customer-facing application, the application that sometimes are the face of the bank with consumers. They would try to move these things into the cloud, make sure they can update them whenever there's a new iPhone coming out or new mobile type coming out. You'd want to make sure you adjust to it as soon as possible. So most of the processes and the things that have been successful have been about these more of agile new apps rather than the traditional ones.
So Matt, what's your thought on that? What are some of the stories you're hearing from out in the field?
Yeah, absolutely. I think Ben's absolutely right. What I've seen customers be most successful with is when they take those applications that maybe are not handling as much sensitive data, right? And those are the ones they start with, right?
So when you say that, I just want to just interrupt quickly.
Sure.
When you say that, how does it affect those people on those teams? When they're going out there and they're building those applications for those customer-facing applications, as Ben was referring to, how are their teams changing? How are the workflows changing? And does that help them then, I guess, adapt then to the more core applications?
Yeah, I mean, I think it's, with any organization, some organizations, I mean, even beyond just developing these edge applications, a lot of them are going through a transition with just moving from waterfall development processes to DevOps. So that in and of itself is a massive organizational change that impacts, people, process, and technology. But I think as far as, the processes that those teams are following, these smaller applications, right, that are usually being broken into their various different component parts, right, with microservices-based architecture based on containers, this changes everything in terms of how these processes and how these apps are being developed. What we've seen organizations do successfully is, number one, they're understanding one of the things that microservices has helped them to do is to understand just how the applications are interacting. Before, when things were just focused on one large monolithic application, it was actually fairly difficult to understand all the different interactions that that application have. And so now when you're working through with microservices, although there's more complexity with microservices, it's much more easy to understand what those individual microservices are doing.
I want to add something specific to that. I've worked as a developer early on I worked at Microsoft at the time, and it was kind of funny because we always had a setup team. And in modern software development, you don't have a setup team. The setup team, the same people that used to be in charge of creating the setup, the package and all that, actually have a new job. They're actually the DevOps team. They're in charge of delivering and building a very agile deployment mechanism into the public cloud. Sometimes they're in charge of the cloud configuration as well. Sometimes it's the former IT people that are in charge of the cloud. But you see actually two things. You see people change their what they know. Just they have to transform themselves because they're no longer, their job is relevant. And the other piece is actually, you see these teams sort of come together because the IT team suddenly working even tighter with the setup team. And there used to be a QA team, test team, and usually in a more advanced organization, you used to get that team in favor of test automation team, people that would build test automation. Suddenly the test automation team needs to also understand DevOps because they're transforming the way you do test into A/B test or some other form of automatic test, which they were doing before, but now they have to work with the former setup team and IT team, and that team to create a sophisticated, sometimes A/B testing, sometimes staging environment, what used to be called smoke tests. So it's brought together some of these teams that used to be a little bit different, and also made them learn new technologies that are supporting that delivery mechanism.
So considering those patterns that I believe are also happening in other parts of the this technology community, customers and vendors alike, how do you think about the supporting technologies? How are they changing?
So the supporting technologies, you could probably, first of all, you have to look at, again, the people. And there used to be like two teams. There used to be the team that has to do with production and the team that has to do with development. And there's no longer two types of technologies. These technology actually span from one side of the house to the other, and also the supporting technologies like security. So if you look at, and I'll refer right now to security, if you look at Palo Alto Networks, so it used to have only a product that focused on networking, firewalling, then things that were on that side of the house. But when you look at the Prisma set of products, you see that the architecture, the thought behind that starts from when the developer actually checks in the code all the way to production. And if you try to break it into two separate sets of product, you're missing a lot of the information. From security perspective, you can learn a lot from the automation about what's actually supposed to happen in production. So suddenly the runtime environment needs to get inputs from the automatic setup in order to understand what is an anomaly and what's not an anomaly, because there's no longer a setup guide. So you don't have someone configure what's an anomaly. You actually learn from the automatic process what's an anomaly. If you look at vulnerabilities, in the past you can get some information about what's a vulnerability and what's not vulnerable. But today you can actually see what's running in production and whether that vulnerability applies to your production. So this whole notion actually creates products that are not about walls between stuff, but products that need to learn from the different pieces throughout the pipeline.
So what are you seeing in terms of supporting technologies that come with this shift?
Yeah, so I think similar to what Ben said, I mean, what I'm hearing from the field, I get the opportunity to go out and meet with, hundreds of different customers and speak at all types of different events and work with, just different companies all around the world. What I've seen work really well is, those organizations, right now, the vast majority of organizations that I've had the privilege to work with, unfortunately, they still have DevOps, right? They have DevOps, which is a good thing, but security for the most part is still a separate function. what we're starting to see as part of this whole move that we've been talking about in the industry, DevSecOps and shift left, is that is now where security is becoming more and more of an embedded part of DevOps, right? So thinking that I think the best way to think about it is simply, security transforms to just be another component of quality control, right? So quality is something that if you look at, manufacturing facilities that produce physical goods, quality control is something that's natively built in at every single part of that development process. And so I think, there's some things that can be taken from looking at modern manufacturing and into modern software development. And that's really what DevSecOps is.
Moving into that DevSecOps discussion, I would like to talk about changing roles because that does get into these talks about adaptation in many ways. And Jabo, I wanted to ask you this question. How do security professionals fit into the workflows and processes that come with app-centric architectures? Because that's really what we're talking about.
In my opinion, security professionals should sit beside the application developers and do the coding together. Security is everyone's responsibility. Security professionals share knowledge with application developers, and application owners help security guys or girls to make sure the security controls would work for their applications in the early design and development phases. So my 2020 focus will be to shift left. For example, currently we detect vulnerabilities for containers in runtime. The challenge was that the volume of alerts are just too big for anyone to consume. At the same time, the application owners were notified without adding details how to fix. So to solve these problems, we would like to shift security responsibilities all the way to the left, so that instead of reaches after the application developers as security team, they can develop the code with security as part of the code altogether.
Matt, what's your thought on that? Because we are talking about these application-centric architectures, and the security teams have traditionally been bifurcated to some extent, and now they're, as you're saying, is shifting left. Right. Perhaps you could help us define this concept of shift left, and what is the role of the security professional? Because they really define a lot of the strategy for organizations.
They do, and I think this is another area where I've seen a lot of movement starting to happen. We're not quite there yet, and so I think what's happening is we're seeing security teams. Like, one of the questions that I love to ask when I'm speaking before an audience is, especially if I know it's mostly security professionals, is to ask, how many people in here have a software development background? And typically it's, maybe 10% of the audience. And so that right there explains why there's been so much of a disconnect over the last few decades in security, is because, these are people who came up with either through audit or through network security. And so the change that I've seen happen is, security teams are having to become coders in a certain way. They have to understand what is actually being developed. And so one way that I've seen teams start to do this is through infrastructure as code templates, right? So security teams have always been really good at creating policies and standards, but most of the time those exist as paper, right? So infrastructure as code, whether it be Terraform, CloudFormation templates, those types of things, those are ways that security teams are starting to get involved and starting to do that. But I still think we're just right at the beginning.
What are you seeing at the beginning, Ben?
So we're seeing in the beginning, most teams typically start with two important pieces in regards to security. First, and it's kind of technical, but they need to create an automation around what the developers are doing, security automation. That means that you have a CI/CD pipeline, and you just gave a free way to developers to put things into production, and you no longer have the option to create speed bumps. Okay, so because you cannot slow down the process, so you have to think about how you're going to use their power. You could give them you can move out of the road anyone who's not doing what it's supposed to do, but you cannot slow down the entire traffic. And so you need to think about speed cameras rather than speed bumps in that sense. So that's the most important piece. If you get that piece right, The next one, which is almost as important as that, again, for beginners, would be visibility. Because just think that as a security person, you have no clue what's going on. You know that people are using the cloud, but you need to get some kind of basic visibility. Some of it has to be top-down about like, okay, I have my cloud, I have all these different things. What am I doing wrong? The other piece is thinking about your app. I have all these little pieces. Where are they? I need some kind of visibility mechanism. So it's really important to create some kind of a canvas where you're actually seeing the different things. You have a security understanding of which ones are vulnerable, which ones are not, what's wrong, what's not. And these are the two important pieces that people start with. Later on, you could add to it, more advanced control, more sophisticated control. Think about traditional security and how you plug that into that environment. WAFs, intrusion detection, am I covered, am I not? What is anomaly detection in general in this space, etc. But I'd start with these two things.
I'm curious about why you really need to do all these things. And I think of it a lot as about how cloud architectures work. They're distributed, they consume APIs, they publish APIs. That leads to an ease of use, allows to real developer happiness. But we also have these issues that we are seeing coming up, such as what we've seen with Docker Hub, what we've seen with NPM. And you talk about speed bumps. And how do you anticipate these new issues that come with these really space age, in some respects, attack surfaces that we've never seen before?
That's a really good question. I'm pretty happy that I work in the security space, and a lot of people ask me, hey, is there even room for a security space in a world where there's cloud native software, there's cloud providers, and you get a lot of things sort of out of the box? But I believe that at the end of the day, if you're buying a security service, you're not buying the specific technologies that have to do with it. I mean, you do, and it evolves, and you need to make sure that you plug into the right technologies and use the right tools. But at the end of the day, you buy a team of security researchers that sit somewhere. It's almost like a service for you that sit and need to figure out like what the bad guys are doing. And the entire security technological stack is some medium for them to be able to assist you, the customer, in figuring out what's wrong. Now, there's so many, and security is needed more than any other time in history when you don't have these speed bumps, and so that actually the role of security has grown, and these teams have a very important role. And you actually see that even if you look at endpoint security, for example. It used to be like a simple antivirus. That's no longer good enough. Now you have to have EDR. You have to have security research team look into patterns in that. So actually, the more you evolve around technology, the bigger the role of security researchers and the automation of taking the insight that they have to your own organization is important in order to deal with the attacks that you pointed out.
So really study what those security researchers are learning about, so you can start using those practices. I know that container technologies, for instance, are a real interest for security researchers now, which really applies to this whole distributed architectures themselves.
Absolutely, absolutely.
Yeah, so that really speaks to this new generation of technologies and how you think about them, and using security research as your own consultation. And container technologies are now being so much more adopted that they are becoming an attack surface that the bad guys are really watching. And so I guess that's really the core kind of principle that we're talking about, is really consume these to this security research, because this will really provide you with that context.
Yeah, you're right. Most organizations, unless we're talking about a really large financial services company, right? Most organizations don't have a huge threat research team or have any threat research in-house. And if they do, it's typically focused on a very narrow set of problems. So I think that is one of the benefits of working with a company that specializes in, whether it's container security or just kind of cloud security, the entire gamut, is you get an entire threat research team that's working 24/7, focusing on those type of vulnerabilities that are being found. In a recent cloud threat report that we released at Palo Alto Networks, we focused specifically on infrastructure as code. what the threat research team did, our Unit 42 team, they went out and they scraped the internet and they found literally hundreds of thousands of infrastructure as code templates. They then took all those templates, ran them through our Prisma Cloud API scanner, and they found that in about 42% of AWS CloudFormation templates, 42% of those templates that are in use had at least one or more medium or high severity vulnerabilities, right? And so breaking that down a little bit more, we found that about 43% of cloud databases don't have any type of encryption enabled. And so again, this is, we talked earlier in a program around, infrastructure as code, how this has been enabling DevOps to move at scale. What we have found though in our research is that the same level of rigor that goes into scanning standard application code, right, as part of the CI process, is not happening with infrastructure as code. And so I think there's a large gap there, and I think most organizations really need to take a hard look as their organization is probably using infrastructure as code to build various different cloud environments. What I think they need to take a hard look at is how are they scanning that code? How do they know that they're following best practices?
I want to turn the attention back to Jabo and ask a question about how is secure code given the same status as building functions for business requirements? We often talk about the business, but we don't talk about the secure code.
So this is a very interesting question. So we have Palo Alto experts to help us how to do it. But from my view, so there are a few things we can do. First is to focus on developers' experience, because our destination of the cloud journey is providing the developer with a safe place to deliver their code rapidly and achieve the best business results. So if our tools stop the developers from doing everything, then we already failed. So focus on the developers' experience is number one. Secondly, involve the developers in the creation and delivery of the service in early phases. We must provide enriched data to tell the developers what needs to be fixed while they are still developing the code, so that they share the security responsibility as well. The third point is we need to be quick to market. If we don't provide the security as a service at the speed of business innovation, they will just bypass us and do their own things. Last but not the least, we let the application owners to define the security policies to some extent as well. For example, security team wants to do micro-segmentation for the workloads to prevent the lateral movement. But only the application owners would know which microservice needs to talk to which microservice. So the application-centric policies have to be drafted as and tested by the application owners, not the security team. So those are the suggestions from my side, how to make sure the security is in the same status of the business function coding.
Let me turn that question to you, Ben, because it's always been really the focus of software, hasn't it? You're building for business requirements.
Yes, absolutely. Securing the application code has always been the hardest part. Your application-specific code has always been extremely hard, and there have been a lot of false positives in traditional code scanning. But what makes things worse today is that once developers start building libraries for other developers, and one person downloads the other person's library, then you get multipliers of these issues, because it used to be one guy writing one app with one vulnerability. Now it's, with the open source community, it's like one person writing one bug being used by so many other developers out there. What's probably most, or the low-hanging fruit that's most important, is to make sure all the shared libraries that are being used in an organization are being scanned regularly for vulnerabilities. So that's the most important piece, because this is sort of the watering hole where everyone comes to drink for. So
That's a good analogy.
so thank you. So I would start with there. Obviously, I would continue. The code scanning tools are important, but actually scanning the libraries, and we've seen that sort of full stack, including libraries, including the packages that are being installed, the operating system, that are sort of like a code in themselves. Like any person could write these packages, you could install all these things. Scanning of these things and creating compliance around what you can use and what you can't use is actually as important as code these days, when a developer is creating a full stack of capabilities, including code, including an operating system, packages and all.
How is secure code given the same status as building functions for business requirements?
I mean, I think the only way that an organization can achieve that, right, is by having standards. I mean, I'm a huge fan of standards, right? When you look at the companies that are out there that are truly operating at cloud scale, right? Think of the Facebooks, the Googles. The only reason that they can operate at that scale effectively without constantly being breached or having breach issues is because they have standardized both in terms of their application frameworks, the delivery frameworks. Every piece of their software development pipeline is well documented and there are standards for it. So in my view, this has to be something that comes from the bottom up. It can't be something where, if I'm a security professional, I can't just take it and say, hey, I'm going to buy a tool and I'm going to drop it on it and it's going to solve that. Certainly tools are a part of solving the problem, but the people in the process side, understanding it. In fact, I always advocate when a company says, how do we institute DevSecOps? One of the first things I tell them to do is, do you know how software moves throughout your organization today? Do you know how it gets from the time the developer's coding it in their IDE to the time it gets submitted into a build server and it gets deployed and it goes out to whatever cloud you're using? Do you know what that process looks like? Most security teams have no idea, right? Because honestly, most organizations, if they're very large, they probably have not one, not two, but dozens of ways that happens. But I think it's the duty of the security professionals, the security teams, to go out and find out what that process looks like, and then figure out, how do I organically embed security and security standards into that so it happens automatically? As Ben said earlier, right? We don't have the opportunity or the luxury anymore to put gates, right? To say, hey, you have to wait here. I'm going to do all these static security checks. It has to naturally and from an automated perspective happen as part of the development pipeline.
I've really enjoyed this conversation. Thank you for joining us, Matt, Ben, and Jabo on the East Coast. I've been joined by Ben Bernstein, Senior Vice President of Products and Engineering at Palo Alto Networks. Thanks again, Ben. Matt Chiotti, Chief Security Officer, Public Cloud at Palo Alto Networks. Thanks, Matt.
Thanks, Alex.
And Jabo Long. Jabo, thank you for joining us. Jabo is Senior Vice President of Cloud Security at Citibank. Thank you all very much.